lesson builds upon the last lesson, which was about dilations. So today we're talking about similarity, and in Math 8 we want to prove two things are similar by using transformations. So we can use dilations as well as the other three to prove two figures are similar. So here we have two figures are similar if there is a sequence of translations, reflections, rotations, and or dilations that map one figure onto the other. So these steps will make it easier to help you identify the transformations involved to get one figure to map onto another one. The first thing that I would recommend doing is identifying the scale factor. We will review that in the examples, but if you have forgotten most of that, I would recommend going back to section 10.1 and watching that video again. The second step, once you identify the scale factor, is to go ahead and dilate one figure so that it's the same size as the other one. And we're going to state the center of dilation. After we make them the same size and state the center of dilation, then we are going to determine if there's a reflection by looking at the orientation. And if there is, we're going to reflect one of the figures, and we have to state the line of reflection. And by that point, we should be able to translate and or rotate so one figure actually does map onto the other. So now we're going to give it a try with these two triangles. And I am going to tell you that triangle ABC is similar to, so the symbol for similarity is just one little squiggle like that. So triangle ABC is similar to triangle NOP. Alright, so what we're going to do first is identify the scale factor. So what we need to do there is figure out how long one side is, and then find its matching side and find out how long that one is. And since BC is easy to see how long it is because it's horizontal, from B to C is 1, 2, 3, 4 units long. So BC is 4 units long, and the matching side to BC is OP because of the way it's named. So OP is 2 units long. So that means that our scale factor could be one of two things. If we are talking about making ABC smaller, the scale factor would be 1/2. If we're talking about making NOP larger, the scale factor would be 2. And in this case, I think it's going to be easier to make NOP bigger. So we are at step 2 now. We're going to dilate the figure so that it's the same size as the other one, and we're going to state the center of dilation. So I'm going to write my steps down here. The first thing I'm going to do is dilate triangle NOP. With center, and we can choose our own center, but usually we will choose either the origin or one of the vertices. So I'm going to say the center is going to be the origin, and scale factor 2. So that means I'm going to take all these points, and since my center is 0, 0, I'm going to multiply all of the values of the coordinates by 2. So that is what I have done here. I took my original points, N, O, P, wrote down their coordinates, and multiplied everything by 2 to get the image. So now I'm going to plot those points and draw my new triangle N prime, O prime, P prime. So there I have my dilated figure, and now I want to get N prime to be on top of A, because I have to match the N with its corresponding point. So N corresponds to A because of the way these are named. N and A match up in the name. So I can see now that once I dilated it to make it bigger, I just have to move to the left and down to get N prime on top of A. So step 2 would be a translation where xy goes to x minus 2 because I move left 2, and y minus 4 because I move down 4. And that will put the original figure NOP on top of ABC, and therefore they are similar. So let's go ahead and try the next one. Okay, in this next one, I am going to say that ABCD is similar to EFGH. So my job is to write down the transformations that maps one onto the other. And this one, let's go ahead and make the smaller one bigger again. So if I do that, I need to find the distance from A to B. So that distance there is 6. And match it up. So if I match it up, AB matches with EF. So we have to match it with EF, which is 2. So since I want to make the smaller one bigger, I would say my scale factor is 3. So now I have to dilate. So I'm going to dilate EFGH and I have to choose my center. Now, just to show you how to do a center that's not the origin, let's use center F. So to use center F, what I have to do is, from point F, I have to make the side length, EF, 3 times bigger. So scale factor is 3. So that means EF now becomes 6. And since my center is F, I'm going to go, instead of 2 up from F, I'm going to go 6 up from F. So this is going to be my E prime. Now, since my center is F, I'm going to find the distance from F to G, and right now it's 1. So I need to make it 3 times bigger because the scale factor is 3. So it was 1, now it's going to be 3. So this point over here is G prime. Now to get H prime, I have to go from F to H, I go left 1 and up 2. So to get the new scale, I would go right 3 and up 6. And I can see that now I have my rectangle that I needed. So now I have a rectangle that is the same size as rectangle ABCD. And I chose to have the center at F. If I choose the center at the origin, I would still have the same size, but it would be down a little bit. Now I have to, if I look back at my notes, I have completed step 2. Now I'm going to do step 3, determine if there's a reflection by looking at the orientation. So the orientation of ABCD is counterclockwise. The orientation of EFGH is clockwise. So that means that we had to have a reflection. So now I'm going to work on reflecting. So step 2 is going to be a reflection. I could really reflect it over any line I choose, but I should decide, should I reflect it to the left or should I reflect it down? So the way to determine that is to look at the points. So A should match up with E. So if I look at A and E, if I flip it down over a line, then E would come to the bottom of the rectangle. But A is on the top of the rectangle. A is top left, so we want E to be the top left, which means I need to reflect it over a line to the left or to the right. So I'm going to choose to reflect it. I could choose anything. I'm going to choose to reflect it over the y-axis. So let's see where that puts me. If I reflect it over the y-axis, nothing happens to E prime and nothing happens to F prime. I didn't mark F prime before, I should do that. So E prime and F prime stay the same, but H prime now comes to the other side of the y-axis. So it comes over here to the 3, and G prime comes over here to the 3. So now we have this shape here, where we have this being E double prime. This is H double prime. This is F double prime. And this one here is, that was F double prime here. And let me get rid of that. And that should have been G double prime here. Sorry about that. All right, we're almost there. We have the same orientation now. So the next step is to either translate or rotate. And I can see I need to translate. So it is a translation where XY goes to, and then we have to travel from E double prime to A, because that's what I need to match, A to E. I need to go right 2 and down 2. So right 2, down 2. Which means my expression is x plus 2, y minus 2. And I have successfully mapped EFGH onto ABCD.